Hello and good day to Prof. Aslan and everyone. I'm Alvin Alexander, MCS 201046, a student of Masters of Data Science. I would like to preface this video by saying that this video is in fulfillment of Assignment 6 for Advanced Analytics for Data Science subject. In this video, I'm going to share on the implementation of genetic algorithm optimization using Matlab concerning the vaccination program against new cases of COVID-19 in Malaysia. The data was obtained manually from Malaysia Kini News Lab website, newslab.malaysiakini.com/covid-19/en. The data set has 20 days of data with 4 attributes, which were date of data, number of new COVID cases, number of first doses vaccination, and number of second dose of vaccination. Optimization problem is essentially trying to minimize or maximize an objective according to available resources. In this case, our objective function is multiple linear regression prediction equation for predicting number of new cases based on 2 independent variables, which are daily first doses and daily second doses. We have already performed the multiple linear regression and obtained the equation. Y equal to 3487.591 plus 0.063x1 minus 0.058x2. So, we want to minimize our daily new cases. Our resources are the upper and lower limit of doses. For this specific problem, the limit for daily first dose is between 5,000 to 50,000 doses. And for daily second dose, we can accommodate between 1,000 to 10,000 doses. For calculation purposes, we assign first daily dose as x1, daily second dose as x2, and the daily number of cases as y. Genetic algorithms take inspiration from biological processes such as selection, crossover, and mutation. Here is a typical genetic algorithm which throughout its processes consists of generation of initial population, measurement for fitness for each individual, selection, crossover, mutation, and algorithm for stopping decision. In the search documentation box, type GA. Let's go to Global Optimization Toolbox. Find minimum of function using genetic algorithm. Let's see what we can do with genetic algorithm. We would like to use this particular example as our base because our problem has lower and upper limit for each variable. Then, we would like to output variable to this format. Later on, we are going to use options for extra flexibility. Let's create a new function file. Let's name it COVID. This contains the objective function for optimization. We obtain the equation based on multiple linear regression done earlier on data from Malaysia Kini website. Save the file as the same name, covid.aim. Make sure this file is in the runnable path so it will be detected by our Matlab command window. In the simplest form of Matlab genetic algorithm function, we put only the objective function and number of variables. Let's run this code. Here we get an unfeasible solution because x1 is in the negative, hence we need to put the upper and lower bound to our function. This is the Matlab code with lower and upper bound. Let's run this code. In the example, with lower and upper bound, we get a better answer. We see the remark that the optimization is terminated because of maximum number of generation exceeded. This might indicate that our algorithm stopped before it managed to get to the optimal solution. So we want to have custom option for our genetic algorithm. With custom options, we control each and every step of the genetic algorithm. The clear is to clear workspace variables, format is to allow more readable number, and RNG is to have same result every run. Firstly, We set visualization to plot best and mean fitness every generation. We set population to 200 and create initial population using uniform distribution. For fitness, we scaled the raw scores based on the rank of each individual and do selection using stochastic uniform selection algorithm. There are 3 ways to produce next generation, which are by elite selection, crossover, and mutation. We set 3 elite individuals to be guaranteed into next generation. We set 80% of the remaining to use crossover by scattered method. And lastly, the rest of the remaining individual will use adaptive mutation within feasible range. We set 3 stopping criteria. First one, function tolerance of 0.000001, 50 generations of maximum stall, and maximum generation of 420. Now, let's run the code. Here in the running visualization, we can see fitness value through time. When the algorithm met the stopping criteria, in this case, optimization terminated because average change in the fitness value less than 0.000001, it reached to the optimal value of 5,000 and 10,000, which resulted in the best value of 3,222.89. Each individual's chromosome has 2 genes and there are 200 individuals in a population. Each gene is of type real number. This is a flowchart representation of the Matlab genetic algorithm option previously. Note that from our settings, we know that each new generation reproduced from 3 top elites, 158 crossovers, and 39 mutation individuals, which in total is 200. To visually represent our search surface, we can make a dummy continuous data throughout our function space. This is possible to visual because we only have 2 variables. Let's see if we run this code. The blue side is the minimum and the right side is the maximum. We can expect that our optimal solution is toward the bluest part of the solution area. We have seen that using genetic algorithm, we managed to find the optimal number of first doses and second doses of vaccination that will give the lowest new cases daily. The result is 5,000 daily of first dose and 10,000 daily of second dose, which will expected to give 3,223 new COVID cases daily. As we can see, this is within the lower and upper bound requirement. Thank you for watching and listening to this explanation. If this is a good video, please like and subscribe. See you again soon.